Hi everyone, welcome to Skilled Inspirational Academy. This is free CCNA Day 10 class. Here are the topics we are going to discuss today. The very first topic on the list is we discussed about the Cisco wireless architecture and what are all the AP modes that's available in Cisco. So before that, I want to give you an overview about the wireless architecture. So far, we have been doing the routing and switching, and I hope today we got a different topic. So wireless, um, yeah. Now it's good that in the CCNA syllabus they have added more about the wireless, whereas in the old CCNA there are very limited topics and a limited understanding about the Cisco wireless. So let's get started. Let me open up my whiteboard to give a quick overview and quick run through about the wireless architectures. As always, we just discuss about the theory first and then followed by the practical. Okay, let me draw the access points and the controllers. So what is wireless first? So we all know this is a switch and router, the very typical design we got. And your PCs are connected to this. Right? This is how the physical connection looks like in the wired connection. But even in the enterprise, let me start with our domestic appliance. That's a broadband router. One appliance works as router, switch, and access point. So we all know that we got two antennas here and we got wired ports. We are not using it, but you can connect your PC to it. So this is all one LAN, right? Why do we call this as a one LAN? It comes into one single network. It could be mostly a class C network like this. And your mobile phones, your laptops will be getting the IP address in the 192.168 range, something like 1, 2, your tablet. So how this connection is happening through this antenna, you got a wireless connection back to your mobile phone. So this is an external antenna in the modem, right? The external antenna is actually sending the radio signals back, and your mobile phone has an internal antenna that's burned inside. And through this wireless NIC, you got a connection back to the broadband router. But in the enterprise, right, since in the domestic appliance, maybe we consider, in my house, I got one broadband router. From the management perspective, whatever happens, whatever we do, we generally, maybe you guys may do a change in your Wi-Fi password, I would say. That's the maximum we do, right? So imagine that you got a house with 10 floors, imagine, and you got 10 modems like this. So when I say modem in the domestic appliance, it's a built-in access point all in one device, right? So you've got 4 access points here with external antennas. If I want to make a changes to a second modem, I have to log in this device, right? You initiate a HTTP connection, right? You're the gateway. When you give this in your web browser, it opens up the GUI prompt where you can make changes for your router, your modem. For 341, for you have to make 4 individual HTTPS connection, 4 web browsers, and maybe 4 tabs with your web browser to open up the GUI connection of 4 modems. So I don't want to do that, right? What if I have a design? Let me tell you this. What if I have a design? Something like this, one box. You've got 10 floors. If I make changes to this device as a one centralized box, when I log in this device, if I do a changes, say for example, if I want to make a changes to the modem 1, if I do a changes here, and if I push the config, the configuration be applied to the modem 1. In the same way for modem 2, 3, 4. If you got 100 plus modems, I got one single box to manage all the modems. This is how the enterprise wireless design. So we are not doing a configuration for every access point. You might have 100 plus locations, right? 100 plus branch offices. You may be working as a network engineer and you are managing all these wireless devices. So is it a painful process? Is it to log in every device and do changes? But instead of that, I got one centralized box where what the changes, whatever I do from this centralized box, the configuration will be applied accordingly to all the devices, the intended devices where I want to push the config. So that's a device called as a wireless controller. So I'm just going with your domestic appliance as an example because you guys are seeing, I mean, you guys have a chance to maybe, have a connection with that day by day. And you are very familiar with that. So that's the reason I'm just giving an example about this broadband router always. It's very, from your perspective, it would be very easy to follow up. So that device is called as WLC, wireless LAN controller. So, okay, we got it. What is wireless LAN controller? And the access point that used in the enterprise, that's called LWAP, light weight access point. Why it is called as a lightweight access point? This access point, the wireless broadband router, whatever the configuration you do, that sticks to one box, and whatever changes you do, that's applied to the one single box. But in the lightweight access point, it's not intelligent, even not like your broadband modem or broadband access point, because you got all your policies configuration is inside your broadband, but inside the lightweight access point, all it does is it just receives the connection. It receives the, commands, whatever the configuration you do from the wireless LAN controller, it's just broadcasting this out. It just obeys to the controller. It's not intelligent to make any decision making because you're not going to do any changes on the access points, all the changes you do from the controller. So it just obeys what the controller says and it just broadcasts the signals out. So imagine like this is a master and slave. I don't know anything. Whatever you say, I'll obey and I'll do it. Whatever you command me, I'll just go with it. I have no problem with that because this is not intelligent to think on its own. It has to rely on this WLC to broadcast a signal, or maybe when it comes to the from the access point perspective, it is just a connection extended from the wireless access point. So how this design looks, right? That's very important. How this design looks from the logical perspective, how this design looks. So you got, I'll make it as very simple design. You got one branch office, you got a switch, and you got your access points. Now the perspective only from the wireless perspective, no wired devices at all. So you got one controller. I got two APs, lightweight access point. So the networks, whatever I create here, you in your broadband router, again, you create your wireless network, right? Example, home. And when you want to connect your mobile phone or your laptop, the very first time you see this SSID that's been displayed in your wireless networks, right? In your laptop, here, the same way. So this is my wireless name. In the same way, you see the list of wireless networks before connection. And this particular network, home, that will be displayed. When you click on this, you get connected to it, right? That's how we do a connection. So how do you see this connection? Somebody is broadcasting, right? That's called, we say that's beacons. So beacons is every second it sends a probe. Hey, this is my network name, home. Whomsoever want to connect, get connect to it and give the password. Once you are done, you get connected to this broadband. The same way, I'm not creating the SSIDs here. This is important. I create all the SSIDs and everything in my one home broadband router, all in one appliance. But whereas in the lightweight access point, where the enterprise design, the enterprise access point, lightweight access points, I am not creating any networks here. Instead, I create the wireless networks in my wireless LAN controller here. So that is called SSID. We say in the, the layman perspective, we say it's a home. From the network standpoint, we say service set identifier. SSID is nothing but your wireless name. So for example, I'm creating a wireless something like a test, and one is SIA, Skilled Inspirational Academy. I got my two Wi-Fi networks here that I have created. And what happens? This access point here makes a cap-wap connection. What is that? That's a logical tunnel. So here comes a question. The very first time maybe you guys might be, coming across this tunnels. What is tunnels? So let me make it very simple. Okay, so you're going in a train. You guys have experienced this. It goes inside the tunnel. People anywhere, they're looking at the train. Can you see what's inside the tunnel? What's inside? Nothing, right? It's just covered with the walls and the train is going through the tunnel. From the user perspective, from the people who are standing, next to the tunnel, far away, maybe close to this tunnel, he cannot see anything what is going on inside the tunnel. That's a logical connection. Only the communication happens between the WLC and access point. So there are two tunnels actually created, one for management and one for data traffic. The management traffic, what is management traffic? So this is all about the access point, right? So every device in a network is called a host. So every host should have an IP address for communication. So for the very first time, the access point boots up, right? As I told, this is not intelligent. So it relies on an external device to get an IP address. Some similar to your PC, like automatic IP assignment. This is pre-configured to get an automatic IP address from the external device. Got it? So you cannot define a static IP address here. So it's assigned for automatic IP address, right? Through this tunnel, the data tunnel CAPWAP, it gets an IP address. Maybe you defined your DHCP server here, WLC. We have a lab, don't worry about that. Just try to focus. And if you have any questions, the Q&A session, we'll discuss more about that. Try to follow this. It's maybe for the first time, it's very hard to imagine, but try to understand. We'll have a discussion session where you can ask your questions. I'll clarify. So you might have configured your DHCP server here. Maybe inside the WLC you can configure DHCP. So since this is a DHCP server, it gives an IP address back on the logical tunnel, data management tunnel. Not only that, this is the key. In the management tunnel, the configuration, the management tunnel, the data that will be exchanged, first is authentication and management traffic. Maybe if you have configured your VLANs as VLAN 5 as a management VLAN, only your authentication and your management traffic will be, going across through this tunnel, through this management CAPWAP tunnel. And in the CAPWAP data, your actual payload, actual traffic, something like you want to search a google.com, your actual data traffic is inside the data tunnel. And in addition, if you go further, it will send an AP join message. Very first time, if this access point want to associate it back to this controller, right? Because how the WLC will know who is sending a request, who are you? To figure out that, it sends an AP join request, the access point. AP join request, and it will send back the AP join reply. So once this two phases goes through, AP join and AP reply comes back from the controller, only then the access point gets an IP address. Once it joined the controller, it gets an IP address and it starts broadcasting the wireless signals back. It looks too clumsy. Let me delete this. So that's how the communication is. So when you look at the lab, I think it would be better. So now lab. So as we discussed, this is the lightweight access point. Can you see this? Let me open up my, okay. So this is lightweight access point, LAP. What happens? The CAPWAP tunnel is formed between the access point and the controller. So there are two tunnels, management and data. And can you see, so far we got a wired connection between the switch and the server. But can you see here, you got a wireless connection between the access point and the PC. This is a wireless NIC card. This is not your wired connection anymore. So how this connection established, how it's working, I'll show you that. So to access this device, so generally we get used to the CLI of the switch, but the most of the configuration you do for the wireless controller is through GUI. So how do you access your GUI? Through your HTTPS protocol, followed by the management IP address of the controller. So what is the criteria? So this PC here should have a connection back to this controller. I can initiate a HTTPS connection to access this controller. Whatever changes I do, that's applied to this controller. It's pretty simple. So what are the requirements the access point should have to receive and respond to the HTTPS connection? Let's see that. Let me delete this, go back to management. You see, this is a pretty flat network. Okay, I haven't configured anything here. I just defined by default, what happens, this is one broadcast domain, right? So we all know about that. So this is one broadcast domain now. It's one network, that's 10 network, nothing else. I haven't created any VLANs at all. So this wireless LAN controller that sits on 10 network. And I've assigned default subnet mask. This is a management interface specifically, that's the intention of this management interface is to receive and respond back for the management traffic. What is management traffic? Whatever the changes I do inside the controller, the traffic is actually going through this management port, management interface. So how do I do this? If I give HTTPS 10.0.02, I get the prompt of the controller, right? So how do I do that? Inside the management interface, I have configured the IP address. How do I verify? Is it this controller is capable to send and receive the HTTPS connection? Let me go to management. Can you see this? My HTTPS mode is enabled here. See, packet tracer has very minimum functionality. We can do some changes, but most of the changes that works only in the the real device. But I'll try to utilize the options, whatever the options we have, I'll try to utilize that. So this HTTP mode is enabled. So that's the reason when I opened up the web browser from here, and if I give the management IP address, I can access this controller because this is enabled here in the management. I always suggest, see, this is a very good tool. Being a packet tracer, the previously, I don't think we got this option, but you got this controller. The real-time deployment of this controller is too high. It's in Indian money, it cost about 10 lakhs, 15, 20 lakhs. But this packet tracer is an amazing tool. With this controller built in, you can actually get familiar with all the controls and the options you have. Try to utilize this lab. See, this is the first tab you should focus on, the monitor. Can you, what are the information I can see here? See, what is the uptime of this controller? It's 41 minutes. It's up and running. I just created this lab just 40 minutes back. What is the system name? Let's see here. What is the management IP address I have assigned? 10.0.0.2. What is the software version running inside? 8.3.1.1, right? So we'll discuss about this rogue APs later. But from the basic perspective, I see all the CPU utilization is 0, memory utilization is 46%. Redundancy, do I have a secondary controller? You can make a redundant connection, right? See, in the enterprise, maybe this concept is called a failover connection, right? This is your active WLC. This is your standby WLC. You got a cable that's connected between the primary and secondary. Once the primary goes down, the secondary will be functional and it forwards all the active connection traffic. Since I do not have a redundancy, it says it's not applicable. So, and apart from that, what is the most, so this feature is not supported on packet tracer. This is not supported on packet tracer. If you can see the traps, the logs, all the latest information about that. Can you see the current client? We got one client. Since this is packet tracer, I have limited with the options, but if you open up in the real devices, you might see what is the client IP address details, right? More information about the client, MAC address. It gives more information about that. I think for the access point, you get some details. Can you see this? I got 2 access point, right? that's actively associated to this controller. This is IP address of the first access point, and this is IP address of the second access point, and it shows the model of the access point. MAC address, uptime 42 minutes 22 seconds. The admin state of the access point should always be enabled, otherwise it's not functional. If in the real device, when you click on that, you can disable and enable this admin state. If you disable that, the access point may be physically connected, but it will not forward any information that's been sent from the controller. That's never going to broadcast that out. So what is the other thing we were discussing about? The SSID, service set identifier, right? So what is the name of the profile? Test. And what is the name of the SSID? Test. The admin state should be enabled here. If I disable this, you won't see the signal. Your signal will be dropped. Let me try to do that. I think this is applied. And go back to, can you see? Now the connection between the laptop and the access point is not active anymore. Why? I disabled the SSID here. Even though I have configured the SSID, I disabled this. The same thing, the same option that's applicable for your access point admin state. It should be enabled. If you disable that, your access point is gonna, drop your connections. That's not broadcasted anymore. So if I make it enable and apply, I should see the connection back, right? Can you see this? I got a connection back. As I told you, packetry is a very small tool, but for your wireless perspective, the real lab, it costs you about 15-20 lakhs, believe me. So try to utilize this lab. And if you go to this level of understanding, and if you learn about all this, this will definitely help you for your CCNA exams. Those who have really, you have a desire of getting your CCNA certification, I think you definitely make use of this lab. Very less expensive, just an application that's doing all this. Really, for the first time when I saw this, I'm really surprised, because you get most of the options. Maybe some options you cannot do, but this is giving more details. So see, we will discuss about the PoE in the later class. This is power over Ethernet. It's giving the details about that. What is the speed and everything, from as it looks like, the real-time device. The mode, what is the mode? The flex mode. We'll discuss about the modes, but for now you get all the information exactly like your controller, the real controller. This is really amazing. This is not possible in some time back, but in the new packet tracer they have given all this option. Please utilize this option again. So this is the first thing. I have created a WLAN, the SSID. So what is the configuration I did inside? I'll show you. So first thing, I have to create a profile name and the SSID, and I should enable. And the interface group, it should be a management. Then says security. Here comes all your wireless connection. You should concentrate on your layer 2 security. And most widely used security is WPA2, that is pre-shared key, where you give your password to connect, like your broadband router. And other than that, the WPA2 supports the AES encryption, the most advanced encryption. If you actually see this is PSK, pre-shared key, that stands for PSK. And I have given a password. Here, the password is, it's case sensitive, C capital, SCO @123. So there is some requirements, okay? When you give use the password, the password requirement is you have to use your uppercase followed by the followed by the numeric value. What do you call this? And all that, special characters. Yeah, special characters. It should be a combination of uppercase, numeric, and your special characters. So the layer 2 security, there are two layer 2 security that's most popular and used in the enterprise. One is pre-shared key and .1x. And .1x then further divided back into two type of authentication. One is using certificate-based authentication, and another one is, username and password. You can do both. But here, to give an overview, since the first day of wireless class, I don't want you guys to give more information and to confuse you. So I made it very simple. Let's go with a PSK. It's a layer 2 security. I've applied this, and what it does, whatever I do here, this WLC, and I got a switch here, and I got an access point. I got a CAPWAP tunnel. So inside this CAPWAP tunnel, all this information is sent it across, your VLAN information, your name, and all this information is encapsulated back and send it to this access point. And this is just doing a broadcast. Okay. So let's move on. So I applied this layer 2 security, PSK, and I've given the password. Layer 3, none, nothing. I haven't configured anything. AAA servers, we'll discuss later. That's it. Very pretty simple. Created a profile, enable this, and enable a layer 2 security, pre-shared key, and I have given the password. Once I am done, what I've done from the access point perspective, go back to the access point. All you can do is just you can assign this access point for DHCP to get an IP address. So what is the IP address assigned to this access point? It's 10.0.0.3. So where is my DHCP server? This is my DHCP server. The services, DHCP, I have to enable this service. I've given the pool name, and the starting IP address is 10.0.0 and it's 255. So total 512 usable IP address I can use. And this access point got an IP address in the same range, 10.0.0.3, and the access point 2 got an IP address in the range 10.0.0.4. And the connection between this laptop and this access point is a wireless connection. See, this wireless 0 is up, and it got an IP address 10.0.0.8. Let me try to stop this. Okay, I don't think I can hold on with that. Okay, so this is the interface where I've configured DHCP, and it got an IP address, DHCP IP address. And you should check from the access point perspective. Can you see the CAPWAP status? Since I cannot show that, see, this is in the very third line, 1, 2, 3, 4, 5, 6. The sixth row, CAPWAP status, that should be connected. And what is the WLAN that's broadcasting? Test. Did I do anything here? Nothing is inside. It's not capable to think on its own, just receiving the information from the WLAN, that's wireless LAN controller, just broadcasting out. Just broadcasting like an L1 device, not intelligent. The basic requirement is it should be on the same network, not necessarily in the flex mode, but for now here, very simple design. All the devices are on the same VLAN 1, flat design. Nothing else configured here. Can you see? All the ports are in VLAN 1. And this has a connection back to this. I didn't do anything at all from the access point perspective. All I have to do is here, the configuration. So once I connect this access point, and once it gets an IP address, that's it. It forms a CAPWAP tunnel between the access point and the controller. One for data and one for management. 2 CAPWAP tunnels should be active. And this is a wireless connection between the PC and the access point. Okay, from the PC perspective, what is the configuration I done? This is important. The wireless 0, since I have configured the pre-shared key 2 here, can you see this side by side? I have given the layer 2 security as WPA and WPA2. This is WPA2 PSK, and this is the password. As I told you, this is C uppercase followed by Cisco at 123. Once I give this PC is try to negotiate to this access point, say, hey, you are broadcasting the test network. I want to join. Can you see this SSID? Manually, I have given the SSID test and I want to connect, and this is my password, and it makes a connection back. So this is a pretty simple design. Okay, and the access point has two modes. CCNA questions. Please be focused. So for the access point, there are two modes, flex mode and the local mode. Okay, let's come to this. What is flex mode? The cost of the access point, it goes up to 25 lakhs. Can I have can I have a WLAN controller in every branch office? No, I cannot deploy that. I can have n number of access points that cost me around 2 lakhs. That's fine. But I need one access point. If it supports 7,000 access points, if I can connect and manage, I can definitely go with that, right? The same ideology is with the wireless LAN controller. The flex mode comes into the picture. This is a pretty simple design. This access points are running on local mode because I have connected my access point to the same branch office. But if I got if I have multiple branch offices where I got, 6,000 access points, how can I afford a 50 WLAN controller, but instead I have my controller in my data center, right? All this access point makes a cap-web tunnel between the controller. Let it be whatever the information, whatever the configuration you do on the wireless LAN controller, through the cap-web tunnel, it sends this information back to all the access points, all your 6,000 access points. You can do the deployment. How? That's the use of flex mode. What is flex mode? Okay, so why I need why I need a wireless LAN controller? That's the first question. For authentication, it cannot think on its own, right? So very first time when this PC connects to this, what is the authentication it's used? Pre-shared key. That's how it's saying, hey, I want to connect to you, but with the password, pre-shared key. This is authentication, right? For this authentication, this access point has to allow or deny my PC. Because I've configured everything here. This access point is doing nothing. It's just broadcasting signal. So this authentication has to be done by the controller here, allow or deny. So hence I have given the correct password, Cisco @123, and this uppercase. I am authenticated, allowed, and I have a connection back to the access point. So only for this, I need a controller. So what happens? See, all your access points, 6,000 access points, got 600 users, very minimal, I'm saying. If all your traffic is going back to the wireless LAN controller and it's going back to the internet router and it's going back to your internet, what will be the impact for this wireless LAN controller? It's highly impacted. It has to receive the traffic from the 600 users. I don't want that to happen. So instead, the ideology of Flex Connect, only for my authentication, I have to rely on the controller. Here it's WPA2. Once this authentication is successful, I'm not going to, rely on this controller. This Flex Connect will take care of that. What happens? It's called as local switching. This is very important. They say what is local switching on what is central switching. Central switching is all your traffic, all your data traffic, all your management traffic, everything is going back to the controller and it's handled by the controller. That is centralized switching. Whereas in the local switching, only the authentication process, for this authentication process, the access point will forward this back to the controller through CAPWAP tunnel. And once it's authenticated, all my VLANs are local to the switch. This information, all these packets will be forwarded back. Sorry, from the switch perspective, I would say frames. So all this VLAN information will be forwarded back to the switch. And from here, the switch should be connected to my internet router. And through this internet router, I can access everything, whatever that's hosted on the web, your google.com, your facebook.com. Everything goes to the local switch from this access point local switch, and it goes to the internet router and it goes to the internet. This is called as a local breakout. I'm breaking the connection locally instead of going back all the way back to the controller. This is important. So this is local switching. So when the local switching happens, only the AP runs in flex mode. So what is the mode I'm running on the access point now? What is the mode that's configured for the access point? That's flex mode. So flex switching is happening, local switching is happening here, right? Going back to the access point, actually see the mode is flex mode. By default, the mode is local mode. You might get a question, what is the default mode for your access point? That's your local mode. You have to change to flex, only then the traffic, something like this. If you got your WLC and this is your PC, all your traffic will be it will go through your IR router, internet router, not through the WLC and back to your router, the main head end router. We call it as the, for example, here the data center main internet router, where all, if your design is something, all your traffic has to go all the way back to the controller, and from here the traffic should be forwarded back to the head end controller, and then it should reach the internet. That is called central switching. This is not recommended at all, right? I don't want all my PCs to go back. It's a long hop. It's just a 1-2 hop away. I have to go 1, 2, 3, 4 hops away. So instead, within a 2 hops away, I can reach the internet. That is the use of Flex Connect. I assure you, this is, the topics and the discussion we are doing it right now. This is a CCNP level of wireless understanding, the wireless concept. So my focus is to give you a deep understanding about every single topic we discuss here. That's the main agenda and the intention of our academy, to give you the best. So you can see the status of the LED, the way you got a connection back to your switch. The LED with green light, that's a connection going back to your switch. So right now you have to focus on 3 key things, how the controller can be accessed. And you got one more CLI also, but I think that's not possible with the packet resistance is very limited. I don't think you can do SSH configuration. The configurations are very limited here to provide an access for CLI. See, new SSH connection allowed, no. New telnet connection allowed, no. And we do not have any control to provide access to SSH and telnet. But in the real world, you can make this as up or no, yes or no. But the configuration is very limited here. Let me try to see if you see any logs. So you can see the port status is up and running. You see the dates, right? This is April 12, and you got read and write permission. The port status changed. You get all this log messages. This is called syslog information. Your device local, your interface, your WLC interface status. Is it up or down, all this information. You'll get right from this logs. Other key things to consider here. I've created one WLAN. I have shown you this is WPA2 and authentication is pre-shared key. You should know about the outputs. The security policy is layer 2 security, and this WLAN is enabled. And then this gives the controller information. I have given this name. You can change your own name. This lag mode we'll discuss later. For now, it's fine. First day of class. I can see from the wireless, I can see the all the access points connected. If you connect 10 access points from, as I told you, from one centralized box, I can manage all these devices from one centralized box. I can see the status of everything right from one single console. The security, we'll discuss about this radius authentication later, and this management we discussed. This is a basic commands, you can use. This is just a time and date, but in the real world you can actually, if you want to upgrade your controller, this is running with a firmware XXX and you want to go with YYY, so you have an option to contact your TFTP server, trivial file transfer protocol, right? That uses UDP, user datagram protocol, connectionless. It's used for very very small size files, something like 500 Mbps, something like that. 500 MB of data you can get from you got your TFTP server, and you can initiate a connection from your wireless LAN controller, and you get this firmware from this TFTP server. You can do all that from this console command. You can have the commands to run between the TFTP and vice versa. You can do all that. The real world, the help option, you get the information and the feedback. This is all limited, sorry. So the main key thing to focus is here. You can see the interface status as we discussed, and you can see your software version, all your connected APs. Two things. So what are all the access points connected to it? Number of access points, is there up and down, or if it goes down, it will show it as a down here. And your clients, currently there is one client connected. Since the packet tracer, I do not see much detail, but you can see number of current clients connected to your access points all in one box. From this controller, I can see all this. You can also actually see the show CDP neighbor command, the same command here. From this controller, you can see actually in the real world, you can see this is a switch connected to it. It will with the show CDP neighbor detail, it gives the output about your switch model, firmware. All this information will be displayed here. Show CDP neighbor output, here it will show. And here if I go back to clients, packet traces limited, okay, but it will take me to this option. So here I can see one active client connected to it. So let me test. I don't know how far it works, but let me try to delete an access point. Go back to physical connection. Let me remove this power connection. The access point is down. So let me go back to my controller and see. Let me refresh this. Okay. Let me log out and log in back again. Still it's showing me 2 access point. Let me switch back to the modes. Still I have a connection back. This is down. Let me shut down this port. See, packet tracer have some limitation and you see some bugs. Okay, but that's fine. for learning perspective, you're getting more. It's not a real device to give us the real-time notification, right? Shut down command. Go back. Okay, that is not available. It's not showing me now. Go back to monitor mode. Refresh. Log out, log in back again. Okay, I think it's a bug. But if you see the number of access points connected, can you see the IP address is 0? There is no, the access point operation state is down. There's a MAC address. So generally you should see the real-time changes as in it change from 2 to 1. The down state change, it will be incremented to 1 here in this case. Okay, guys, quick, 10 minutes Q&A, because this is the first topic about wireless. If you have any problem, you can ask your questions. Let me try to, I think you can unmute yourself, right? To unmute yourself, I gave the permission. You can ask your questions if you have any questions about the wireless concept we discussed today. Hi guys, I'm audible. Everybody can hear me?
Audible, sir.
Hi, yeah. Hello?
Yeah, hello.
Yeah, I can hear you. Yeah.
Yeah, okay. I just want to know the CAP app is the protocol that which you are using. It is by default or inbuilt configure on WLC as well as on AP.
Yeah,
Right?
that's by default. When it makes
So
a communication, see what happens. I'll tell you from the D perspective. This would have this MIC certificate, manufacturer installed certificate. That stands for MIC in the real device I'm talking about. You got this MIC when Cisco ships this to the customer. You got this MIC certificate. It is that's pre-configured on both your, that's been pre-configured on your wireless LAN access point and your controller. So once this negotiation happens, right, this CAP web tunnel will be up and running. This certificate exchange happens. So to just to recertify themselves, okay, your Cisco device, okay, you're this access point, okay, our negotiation is done. So we form a CAP web tunnel. That's how the CAP web tunnel happens between the controller and the access point. That's by
okay.
default. By default.
Okay. And actually, this is all about the Cisco devices, right? And what about the other AP? Like if we want to connect some other AP apart from Cisco manufacturer, then it will also be able to.
I think Aruba is using a GRE tunnel. They're not using CapWrap, if I'm not wrong. I because so sometime back, 4 years back, when I worked with Alcatel-Lucent, where some people they work for Aruba, they keep saying they use GRE tunnel between the access point and controller. But I want to give you a concrete answer, so I'll answer about that tomorrow. But that's again, I'm not 100% sure about that, but mostly I think 90% it would be a GRE tunnel between the access point and the controller.
Okay. No, I'm okay. One more thing, like if I'm using Cisco WLC, can I use apart from Cisco AP? Can I use some other vendor? And
no, that is not possible, right?
that's not
Because
possible,
as I told you, the MIC certificate has to be in both appliances.
Got it.
For the then the certification exchange will be dropped and the exchange will not happen.
Okay, got it. Thank you. Yeah.
Okay, no problem.
Good evening, sir. Can we
good evening.
captive portal via WLC?
Yeah, definitely that is possible. I think here I don't think we have an option.
What will be the authentication mechanism?
Okay, that's actually a great question. Really, guys, you guys should appreciate him. See, for this captive portal, we generally using MAB. You know why they are using MAP? Bring your own device. BOD. You heard about that? Definitely, right? That is something you are going to a network. Sorry, you're going to an enterprise just as a guest user. So you are actually carrying your own device. This is bring your own device. You got your mobile phone. So what is the authentication mechanism used here? For WPA, I use a password. But for this web authentication, I use MAB, that is MAC address bypass. What it exactly does, the username and password would be your MAC address. Right here, I configure the map can be configured in both ways. One through your WLC, and the most deployment, I would say, this controller have a connection back to your authentication server. Most probably it would be we are using ICE here. Is identity service engine. Here the ICE is again connected back to the AD controller. So what happens? You are a guest inside the AD. Definitely your username and password will not be stored because you are not an employee of XXX organization, right? Because you are not part of this network at all. So you are having your mobile phone, all you have your MAC address. So this MAC address can be utilized as your identity. Hey, I am AAAA. This is my username and password. Authenticate me. Since we enable this MAB authentication for captive portal, so once you connect to this SSID, it checks, okay, this is MAB authentication. I got the MAC address of your mobile phone or your laptop. Okay, done, and you are authenticated back and you're connected back to your WLC. That's how the captive portal works. And I don't know, we have an option to do that. That's pretty it takes too much of config, and I don't think the option is here. Captive portal.
There is also radius.
Can you see this?
Radius and TACAC.
Yeah. Can you see this web authentication? Can you see this options are disabled in the packet tracer? Here, actually, if you go to security and if you enable this web authentication, right? Can you see this? This is a little bit of grayed out. That's web login page.
Yeah, it's visible.
Yeah, you can do a configuration. You can enable MAB from the controller perspective, and if not, you can inside your ICE, you can enable a MAB policy. Here you can define, see inside this web authentication, it will ask for your AAA server configuration. Here you can define your ICE configuration. Something like 10.0.0.1 is your ICE. You can define here, and you can define your MAB policy. So based on this SSID, this ICE server will reply back to your MAB request.
Means we need to ICE or radius at TACAC. For the
TACAC, I think so, but I have to check on that. I believe the web authentication can be done locally. I have to check on that. I'll tell you. I mean, I'll go through that and I'll explain you tomorrow about that.
No issues.
But for now, I mean, I get used to. We used to manage this through ICE. We have the policy applied in the ICE, but in the controller, I have to go back and I'll check that in my controller and get back to you.
Okay, sir. Thank you.
No problem.
So in MAB authentication, we do not, it's not required to put any guest ID and password. It's just like we need to connect to the SSID, right?
Yeah, that's amazing. Yeah, you don't need to give anything at all. All you have to do is just connect to your SSID, and with your MAB, that's it.
Okay.
You're connected. Yeah.
Is that a breach of security? Like if anyone can log in and just to find out the SSID and just connect to the SSID?
Even I had the same question, but the Cisco said, you have at least you got the MAC ID information, right? You get you get ICE logs. It says, hey, at this time, this guy is connected. This is his MAC address. So if some traffic is you are doing some vulnerable, if you try to exploit the network, will at least have some kind of identity. Some of your MAC address, okay, this MAC address, this doing a lot of communication back and doing all this, to try to exploit the network. some identity with a MAC address. And yeah, that's actually a good question. But your MAB authentication doesn't see in the captive portal. You cannot access your local network at all. Do you know about that? See, yeah, I missed to say that. See, this is your mobile phone, and once this authentication server authenticates, the policy, they apply an access list. You know what the access list they have defined? They first deny your guest network. Maybe your 172.0.0 is your guest network. You get this IP address. Okay. So they block this traffic to the internal local LAN. If my local LAN, all the appliances got running on 10 network, the first command they apply in the guest login, right? Because you definitely need a switch to send your traffic back and forth. So inside that, they apply an ACL and they block your guest traffic with the local network. All my enterprise local network will be blocked. So only your 8.8.8 and 4.4.8.8, all your hosted internet connection will work. You cannot connect back to the local network at all. Sorry, I missed this point. You have this ACL and they deny this because that's a security hold, right? It's actually great question.
Because of we can buy the USB dongle within 150 rupees, and we can use them and throw out.
What is that? What device is that?
That is wireless adapter, only 150 rupees and 300 rupees.
Where you will connect that adapter?
USB device. We can misuse the network. That's why this kind of facility available inside LAN. We cannot enter.
No. What is the intention of connecting the device? I mean, what you're trying to hack?
Actually,
I mean, what you do exactly?
Actually, you told us now, right now, कि, any single identification you have to note there. So MAC address is the unique address. We can find out who tried to access our networks. That's I told this. We can buy 300 rupees to 400 USB wireless adapter, and after the vulnerabilities activity, we can throw out.
So you mean to say this, right? Okay, I got you. So you mean to say you got your laptop and you got this 150 rupees your adapter, and with this NIC card you have a connection back to the access point, is it?
Yeah.
And you do a manipulation with this adapter and you'll just throw this away and
Yeah.
do your vulnerability.
Yeah.
Okay, I'll tell you. Even though this adapter, can you think you can hack the local network?
No. That is the answer. That is the exact answer. We cannot enter the local pool. We cannot.
Okay.
That is
Yeah.
a good point. That is a good point. That's why.
Okay. No problem, sir.
Okay. Thank you.
No problem. Yeah. Actually, this is great questions, so interactive. This is what I'm expecting from everyone. So this is more. I'm happy because you guys are getting the concepts right. That's great.
Yeah.
This is needed, man. This is something is going inside your head.
Thank you.
So this is the level of understanding you should have. So that's the reason I keep insisting everyone to focus more on the basics, your ideology, then you can play around with that. But without basics you cannot do anything. Make utilize of this class. This is actually, I'm trying to give you as much as information. I'm just not giving you the basic abstract about every concept.
I will also make a little network for the wireless controller. I'll make after the class.
Okay, so you want more concepts about wireless?
Yeah, sir.
Okay. Sure. We got so much coming up for wireless. We got radius, TACACs, what is external authentication servers. I think we got a couple of concepts to cover for this. Is very high level overview of wireless today.
Yeah, sir.
So I have an intention to buy the real appliance, but that costs more. So that's the problem. We can play around with the real device. Even the old, I think 3500 series, it costs about 5-6 lakhs maybe in the eBay.
No. It's more about the 10 to 15 lakhs.
More than 10 to 15 lakh, right?
Yeah.
So that's a pain, man. That's a pain. But actually, this packet tracer tool, at least you can go through the options. If you cannot work on that, that's fine. But you can go through the options. So what are all the options I got? See, you can see the AP join request. If you drill down, you get more details. With this one application, they actually done really a tremendous job.
Might be after the configuration it will be work. I think it's a great menus will work after the configuration.
No, sir. I think, see, if I try to enable this HTTPS, see, this is by default they enable. Okay, with the developer they have didn't they did this. If I want to make any changes, it says that the feature is not supported in the packet tracer.
Oh.
Yeah, that's the problem. See, telnet and SSH I cannot do. Only the local username and password I think I can do. I can remove and I can add new username and password. But this is for, I mean, as I told you, it's good. At least you can see all the options that's inside every main option.
After the class, please share the IP, share the credentials by default. Packet tracer uses for the Cisco APs and.
Oh, okay. So, no. That is very simple. Okay, I'll tell you. All you have to do is this thing. Go to management. Okay, choose this controller. Where is it? Go to this wireless. Can you see my screen? This wireless, and go back to this controller. I choose this controller 3504. Just take this right from the box and go to config and change the management IP address as per your network design. Here I have given 10 network. If you are going to use this network as your primary network, then assign the same IP address range for all the networks. So the ideology is give the same network information across the devices to make it functional. Got it?
Yeah.
So once you do this, right, all you have to do is go back, close this. For the very first time, you have to open your web browser and you have to type your management IP address. Example, I have given 10.0.0.2. It says server reset connection because now only HTTPS connection is enabled. So what for the very first time, you have to just give 10.0.0.2 and it opens up the option to configure everything. Maybe you do it, man. You do it. And if you have any questions, no problem. You ask me tomorrow. I'll help you out with the lab.
All right.
Sure. Yeah. Okay, guys, I think.
What about the authentication process you told? No, it's a very good question for authentication. It's just for authentication, kind of.
Authentication here, we are using a layer 2 authentication, right?
Okay. Now somebody asked, no, what is the exact process of getting authenticated?
Oh, exact process of authentication. Okay, go back to, where is this web browser? Let me give it https://1002. Log into the controller. What's your name?
My name is Zaya.
Sorry?
Zaya.
Zaya.
Yeah.
This one, right?
India also. Yeah.
Okay, Zaya. Okay, Zia. So if you see, I'll go back to WLC. See, this is a profile I have created, test, and the security is WPA2, and the password is uppercase. You can give any password, okay? But I have given Cisco at 123 because it should be a combination of uppercase, lowercase, special character, and numbers. So I gave Cisco at 123, and I have enabled this pre-shared key. Yeah, criteria, and you have to enable this both. This is by default enabled. WPA and WPA2. No, don't select TKIP. Use WPA policy enable and AES enable. That's it. I haven't configured any layer 3 security because mostly we use only layer 2, and we never use this layer 3 security. This is used for web policy. I think I'll try this lab. I don't know how far it works, but from this the basic lab setup, I'll tell you. Layer 2 security, WPA and WPA2, and I have to enable this WPA2 policy, enable an AES pre-shared key, and then give your password. And how to connect your device. This access point, you're not going to do anything. You're going inside the access point, just giving a DHCP, it gets an IP address. Because it's all in the one flat network, VLAN 1, I have configured the DHCP server here. See, I think you've been the class for last 10, 11th classes, right? So you will understand all this, I'm right? So that's why I'm just running up very fast. So you got your DHCP server, and I have configured a pool with a 10 network. So what happens, this DHCP request, it's forwarded back to this DHCP server and it gets an IP address. Because this lightweight access point, all it does is it gets an IP address and form a CapWap tunnel, and it receives all the information from the WLC and it broadcasts out. So how do I check that? If you hover over this on the access point, you will get two options: CapWap status not connected now. It should be connected and you should get an IP address. Once it's connected, you have to go back, and the laptop, you just hover over to this and your wireless 0. Can you see this? Because I cannot mark with my digital pen. Your wireless adapter, you got an IP address. Go to the same adapter, right? And inside the adapter, you see two options you have to enable. One is your SSID, because test, that is a profile I've created here. Can you see this? This is a profile I've created, test. The SSID, you should not focus on the profile, the SSID, that's broadcasting. So the name, what you are given, the SSID, you have to give here, test. And then you have to enable WPA2 and pre-shared key, Cisco at 123, whatever I have given here, this pre-shared key here, right? This key. You have to give here. Once this is done, you should have a connection. Can you see this? That's the reason I built this lab in the beginning. This packet traces has so many bugs. At times it's communicating, at times it's not communicating. So I don't want to disappoint you guys, because this happened many times. So I built this lab in the beginning, and I'm very sure that, okay, this is working. And we can try that one more time. But for the very first time, to show you, if it is not working, you'll get confused. Because this is pretty simple. You have to give WPA and give your password. But this will work only this CapWap status is up. Here, I think it got some problem. You have to bounce the port.
Okay.
You do this lab, and if you have any problem, and we will troubleshoot from there.
Sure, definitely, not a problem.
Okay. Thanks, man.
Thanks, buddy. Thanks.
What else? I think we are good to close the session. I think everybody enjoyed today's class. So we'll meet tomorrow. Have a great day, everyone. Bye.
Sure, definitely. Take care.
Bye. Yeah, you too. Bye, everyone. Take care. Bye.